Good morning or good afternoon, depending on where you are at. My name is Cathodic Aziz Dinamini. I'm Director of the Innovative Bridge Technologies / Accelerated Bridge Construction University Transportation Center here at Florida International University. We are very pleased to bring to you our monthly June 2026 monthly webinar. The title is Florida DOT Cathodic Protection, Present and Future. And as you know, Florida DOT is very active in corrosion protection, so we look forward to this presentation. We are delighted to have with us Oliver Chan, who is a state corrosion and composite material engineer, and Natasha Brenkers, Assistant State Structure Design Engineer, Florida DOT. We have more than almost 1,000 sites that have signed in to listen to our monthly webinar live. Couple of news related to upcoming 2026 World Bridge Engineering Conference, which is going to be in December 1st and December 2nd. Thanks to 33 state Department of Transportation that they have co-sponsored. The conference is sponsored by U.S. Department of Transportation through our University Transportation Center. The program for 2026 World Bridge Engineering Conference is already set. We have 140 technical presentations. These are majority of the presentations are with the bridge owners here in the US and outside the US. There are 7 keynote talks covering many different topics. We have more than, to date, we have more than 40 exhibitors that have signed in, that have reserved their exhibit booths. There will be a reception. There is an award program that is associated with the conference. This conference also have very interesting workshops. These workshops are, one of them is what bridge engineers should know about artificial intelligence, that nowadays we hear everywhere about it. So this is a very good opportunity to learn about the AI. We have a workshop, all day long workshop on non-destructive testing that is going to be given by 5 different companies. We also have another workshop that I will elaborate a little more on, Sprayville UHPC. So mark your calendar, please plan on visiting us in Miami, Florida. The conference will be at Hyatt Regency Hotel. Registration is open. Please take advantage of the early bird registration rate that will end in August 14th. Reserve your hotel. December is, as you might guess, is a very busy time period in Miami, Florida. So the hotels are gone before you know it. So we still have the rooms available at special conference rate. You can visit the website to reserve your hotel. There's opportunity to exhibit. Also award. The deadline to submit your award nomination is June 30. We also have the Sprayville UHPC actually workshop. This is an automated Sprayville UHPC workshop. This is a robot that you see that we are using it in order to spray the UHPC. December 4, in conjunction with 2026 World Bridge Engineering Conference, we will have a workshop that will be jointly by UHPC Technologies and the FIU. And then there will be another workshop. The date is not set, but we are working collaboratively with Georgia DOT sometimes in 2027. I'm also delighted to tell you that the first US DOT Annual Transportation Infrastructure Summit will also be taking place, which is a separate event in conjunction with the conference. So at this point, I'm going to let Kathy to share with us some additional news related to bridge engineering. Kathy?
Thank you, Atorad. My name is Kathy Kroll. I'm a co-director of technology transfer at the IBT ABC UTC at Florida International University. I'd like to thank you all for joining us today for our 183rd webinar in our monthly webinar series. Before we get started with the featured presentation, I'd like to share a few industry announcements. First, AASHTO's Committee on Bridges and Structures annual meeting will be held next week, June 2nd through July 2nd in Charlotte, North Carolina. Next announcement is our partner university, Texas A&M, will be hosting a live workshop on biochar applications in concrete. This is an IBT ABC UTC associated event that will be held June 29th through the 30th in Bryan, Texas. So right around the corner from a date standpoint. So for more information, see the QR code on the screen or contact Jeff Bullard. So next is the Precast Prestressed Concrete Institute's Committee Days Conference. It will be held September 9th through the 12th in San Antonio, Texas. On September 15th, we'll be presenting our annual in-depth web training. The event is similar to this web series, but it goes from 11 to 3:30 Eastern. session, giving us additional time to delve deeper into a particular topic. This year's topic will be Accelerated and Innovative Bridge Deck Repair. Mark your calendars for this educational event. Lastly, ASBE, the American Segmental Bridge Institute, will be holding their 38th annual convention in San Antonio, Texas, November 9th through the 11th. Two more that are own events is our next monthly webinar will be on July 23rd, which is a little bit later in the month, from 1 to 2:15 p.m. Our colleagues from the Federal Highway Administration will be presenting on structural design with ultra-high performance concrete, UHPC. Please join us, David Garber and Rafiq Halou, for this educational presentation. And finally, our next research seminar will be held on July 31st, featuring FIU's project that is closely related to today's presentation. It's using dog and magnetic fields to accurately detect corrosion in steel strands embedded in concrete. Our own Dr. Aziza Amini will be presenting along with Dr. Furton and Carlos Concha Avia. That's all for our announcements. On to our standard housekeeping items. As many of you know, these webinars are recorded and posted on the IBT ABC UTC website in the section titled Monthly Webinar Archives. So you can access this and all previous webinars for future learning and to share with interested colleagues. I'd also like to point out that a PDF version of today's presentation will be posted in the archives. Lastly, the presentation will be followed by a question and answer session. We have a number of questions that were submitted with registration. With that, we will begin our featured presentation. We are happy to welcome Tazia Brenkus, Florida State Assistant State Bridge Design Engineer, who will be doing an introduction, and Oliver Chung, Florida DOT's State Corrosion and Composite Materials Engineer, who will be presenting on the use of cathodic protection in Florida. Natasha and Oliver, thank you for sharing your time and expertise with us today.
Welcome everyone to this month's webinar, the FDOT Cathodic Protection Present and Future. Today's presenter is Dr. Oliver Chung, and my name is Dr. Natasha Brenkus. I am the Assistant State Structures Design Engineer leading the group on Design Resource and Technology here at the Florida Department of Transportation. The group that I lead focuses on bridging the gap between research and practice, and it develops computational tools and aids for practitioners. Finally, works on implementation of research products into practical design guidance. Today, I have the honor of introducing my colleague, Dr. Oliver Chung, our State Corrosion and Composite Materials Engineer at the Florida Department of Transportation. Dr. Chung's expertise includes construction materials testing, corrosion engineering, and machine learning applications in civil engineering. This focus has helped the FDOT adopt data-driven decisions to optimize the corrosion program and to further extend the service life of our bridges. So the Florida Department of Transportation is responsible for planning, design, construction, operation, and maintenance of our state highway system. It's organized as 7 districts, a turnpike enterprise, and a central office, though it operates largely as a decentralized agency. The central office, which includes the State Materials Office in Gainesville, as well as the central office in Tallahassee, establishes departmental policies, rules, procedures, and standards, and ensures uniform compliance and quality performance by the districts and the central office units that implement our work program. We own and maintain approximately 12,000 bridges across the state, one of the largest bridge inventories in the United States. Infrastructure projects are delivered in the state of Florida through a combination of in-house staff design and consultant engineering firms, and FDOT provides specifications, standard oversight, and final approval on these projects. Dr. Chung is based out of the Florida Department of Transportation State Materials Office, or the SMO. The SMO supports our central office by providing statewide leadership in materials engineering, testing, research management, and quality assurance. They work to develop material specifications, evaluate product performance, and establish testing acceptance criteria to support the Office of Design. Finally, our little plug about the state of Florida. Why would you want to come visit our beautiful state? Well, we have approximately 12,000 miles of coastline, lots of beaches, lots of fun, a warm climate, and year-round outdoor recreation. We have those world-famous beaches, natural freshwater springs, theme parks, and vibrant city life. With that, I will turn it over to Dr. Oliver Chung. Thank you, everyone.
Thank you, Natasha. This is Oliver. I'm a state corrosion engineer, and right now I'm been in servers for 2 years. So I'm still learning, and today I'm going to learning with you. Here's a little bit outline. I mean, everyone know the corrosion, and I always like to start with like 5W1H, like, who, where, when, why, how. So all this will solve my problem, and that's the way I'm thinking. And also I want to introduce a little bit framework of the State Material Office, especially my team, Corrosion Research Lab. And, based on the topic, present in the future, right? How we execution for the CP program in the past and moving to the future. I think at the beginning for the introduction, everyone start to aware of the data-driven AI implementation and how we digitize our bridge or corrosion problem. Like a lot of people talk about the digital twins, all this. So how we use the data-driven or more strategic to manage our corrosion problem. Maybe CP program is a good way to improve that. As I mentioned, future data-driven performance, logistic, and that's what FDOT are moving forward. So start with the 5W1H. What is a corrosion? I'm still learning, like everyone. So in Florida, just with Natasha say, we have almost 13,000, 12,000 bridge considered in extremely corrosion, under the extremely corrosion environment. And bridge substructure is always common affected by the corrosion-induced damage. So introduction, we have a lot of water activity, all this bold and, splash tidal zone. Always you can see some corrosion issue. As you can see, we have something on the girder, we have something on the pier. All this reduce the service life of the bridge. So why does corrosion matter? Here is an example. More information like for the Fern Hollow Bridge is being presented on May. Everyone, I think all the bridge engineer know this accident or incident. So safety, service life reduction, structural integrity, especially the cost, right? Right now to rehab one bridge, we cost a lot of money and the environmental impact. Based on the data, you can see our client is been changed. Average temperature is start to rising annually. So where corrosion happens in Florida specifically, usually for Florida, we have some marine environmental, and in the central Florida, we have a lot of clay, soil, all this receptivity and low pH, and also the hot weather, heat, humidity, sulfate, or others. So the problem is corrosion damage our infrastructure, leading cracking, spalling. I mentioned that before, lose the structural integrity, and that causes a lot of safety and the higher repair cost. So when corrosion happens, so this I'm showing the corrosion mechanism. As you can see, the corrosion happens always come from 4 major components. Anode, the side where the metal ions dissolve into the electrolyte and electron are released, and cathode, the side where electrons are consumed through a reduction reaction, often involve oxygen, and electrolyte, the conductivity medium, the moisture that allows ion to move between the anode to cathode. And metallic path we call connection, the physical connection that allow electron to flow internally from the anode to the cathode. And that's when rusty happen with all these 4 components. Then concrete start to fail. So who is affected by corrosion? I would say public, everyone, all the users. So here's the specific number of the bridge right now, Florida. We have, based on 2025 data showing that it's about 3,400 bridge is over design life. To maintenance, repair for department is very heavily. So how we going to extend the service life of the bridge is a key component, which reflect to how to control your corrosion problem, one of it. And we do some estimate or prediction nowadays. Every year we will, for the next 5 years, we will have additional 550 bridge to bypass their design life. So as you can see, the needs is there. And our current design bridge year, 75 years, but now department have the intention to push to the 100 year because now we start to have a lot of new material, and also people realize the maintenance or the rehab, all these costs, especially restructure, the construction cost is being increased. How to stop corrosion? I will put a lot of way to doing this, especially for Natasia's group. Actually, she's the expert how to design the infrastructure for the corrosion. You can base on the environmental, you can base on the material design, or you can use the chemical inhibitor to stop it, or corrosion resistant material, for example, coating system, stainless material, GFRP, and also the protective coatings. Also the structure design, obviously including the thickness design. So there's a lot of way to prevent or mitigate the corrosion. And the other specific topic is the CP system, which is our topic. And I also provide the actual guide specification for service life design of the highway bridge as a link. If everyone are interested, can visit. So we understand 5W1H. Now, I'm going to jump into the State Material Office, a little bit framework here. We focus on established policy and the procedure for the Florida Department of Transportation of Material Program, specific material. In our unit, we have a structural material, which were mine and asphalt, geotech, and pavement. Our locations here. If you want to learn more, you can go to our website to learn more about SMO or me. My team, material durability and the technology. Some people call us a corrosion lab. So my team, I have 4 arms. One is the corrosion research team, focus on the lab, study when corrosion happen. We're doing the long-term testing. Our longest research right now is being conducted for 30 years. And my second arm is a corrosion mitigation field team, which conduct the CP system. So as you can see, 1975, the first impressed current test has been conducted by Bob Brown. That's a history. And the challenge for me is always like corrosion is not going to happen next day or 28 days. It's happened 30 years. So I really appreciate Bob to have this. And now I can have a more strategy to prevent the corrosion. And another one is a composite material team, especially for the GFRP, plastic pipe, all this material. And the third one is a structure integrity assurance team, focused on the welding, steel bridge, coating system. So each team's function, I mentioned that briefly in the previous slide, but as you can see for the research lab, they will focus on the long-term research. Any material can be used. Nowadays, we hear a lot of the mixture, like for example, type S or any corrosion parameter, how we define environmental classification also is based on our research and work with Natasia's team. If you want to know more, you can go to our standard structure design guideline. The corrosion mitigation CP system, we conduct the corrosion assessment, because before you design the system, you have to understand. Install the CP system or any forensics inspection. Composite, like I mentioned, today is not our topic, so I will going to skip plastic pipe, GFRP, all the stuff. Structural integrity, assurance, commercial inspection, coating system, and the timber. Specific for the field team, highly relate to the CP. My team's function major provides these 6 servers. First, corrosion evaluation, NDE, and the course. And second one is design proper corrosion prevention system, which different type of a CP system I will introduce on the following slides. And the servers also including installation the CP system sometime, but with majority we focus on the how to assist the contractor to doing that. And to the maintenance, calibration, repair, we will go with our contract. And also we provide the independent assurance to make sure the CP system is working, its function is not dysfunction. And also we are looking for new research and the new implementation. The new technology is not going to stop. So that's the other function we have. Okay, the first function, corrosion assessment. Usually when my team go out, first things we need to understand the history. I always like to learn from the history, just like you have to understand when the bridge design, what's the construction methods, or the maintenance record. and the other history about the bridge. Sometimes I treat us like a doctor of the bridge and work with the structure, work with the maintenance. And the second part is the environment. Where this bridge at? Is in between the river or the sea, or just like a key or like island? What's the class of the environment, and how's the weather like that? So for Florida, we don't have a free thaw issue, we don't have a snow problem. We will just focus on the hot weather condition. And area, where's the corrosion area? It's on the girder, it's on the pier, is there's a cracking, is there's what caused this happen? So sometimes we know corrosion could be from the poor construction quality. So NDT sometimes will help us to check all this. And the sample, as an engineer, trust and verify. Once you have all this puzzle, you probably want to verify by coring, sampling, what's the real condition of the current material or the bridge structure. So go to the NDT test. I believe I will show you on the next slide, but most of my team doing is the electrical resistance, surface resistivity, kind of understand the current concrete permeability, because the permeability is also another key component to to affect the corrosion rate and corrosion potential. Check the current. Right now, this structure have any active corrosion happening. GPR, ultrasonic, sometimes we use to ensure the design thickness and the spacing. Do they have any construction quality concern, anomaly, moisture, any leaking problem? That's our current major using on the NDE, and the equipment is for the corrosion assessment. And I just want to mention that 2026 World Bridge Engineer Conference facilitated in the Hyatt Regency. That's a good hotel. I do like it. But before that day, the NDT workshop will be facilitated for the whole day. So just want to highlight that and encourage all the people to join. So I'm just showing you surface resistivity, GPR, ultrasonic, all this equipment we have been actively using in my program. The other challenge for the corrosion is not really today's topic, but I really want to mention that because nowadays we see more and more failed tendon, corrode tendon. So as you can see, once you lose the tendon's integrity, no matter it's internally or externally, will affect. I want to learn more from Natasha, Dr. Natasha. She is the expert of the post tendon. So more to come. Maybe in the future, she can provide another webinar to talk about her strength in the research. So that's another NDT testing for the post-tension evaluation. We only focus on the external tendon. This is kind of from our research project. We have this magnetic equipment, so we can detect where's the corrosion in the tendon system visually. And we're still working on this research, and hopefully we can adopt this technology as soon as possible. So maybe there's some strategy we can overcome the corrosion tendon problem. As everyone know, based on the research, FHWA already concluded that the CP system is very powerful and the good technology has been proved to stop corrosion for the bridge deck or any structure. I just don't like to say stop. I probably will say mitigate, because really you pretty much just slow down the corrosion. But the CP system, CP is an electrochemical method of the corrosion control protection, that take advantage of the electrochemical nature of the corrosion by transfer anode into a non-corrode cathodes. Sometimes I treat the CP system like cells battery. The idea is change that cathode to anode to prevent transfer the corrosion from the key component to the anode. So here's the macro cell. On the structure, you can see where's the cathode, where's the anode happen in the field. So type of CP system, right now, majority, we have two type of system. Galvanic, we also call sacrificial anode protection, more reactive metal like zinc, magnesium, aluminum is attached to the structure, and the chloride instead of the steel reinforced. Pretty much you transfer the corrosion to the other metal. Impressed current system use the external power source to drive a current through an inner anode, offering more control and power. That's usually two different major systems at this moment. I know the CP system usually authentic is from the pipe or the oil company. They use a lot, but with our 30 years experience, this is the type of a system or the anode we are currently using in the FDOT infrastructure. We are still trying, we are still tracking each performance because, as I mentioned before, corrosion won't happen 28 days. Corrosion won't happen for the next an hour. So we need to keep tracking this performance and to find which one is the best use for different infrastructure. And this is just a general galvanic CP system we are using in the department. As you can see, some anode, point anode system, attached anode system, and obviously we use a lot of jacket on the pier corrosion. And this one is an impressed current system. Usually we will connect to the independent power source and provide enough current to prevent the corrosion keep happening. And here is the research. We are trying to use the solar panel. So I will introduce this later. Just a little summary between the galvanic and the impressed current system. Usually galvanic, you don't really need to do any inspection because you are just waiting the active metal being consumed out. And usually based on our experience, it's roughly less than 20 years. So, but every 2 years, we will do the visual inspection and to check the corrosion development and if the system is still functional. And sometimes we have to do some repair. And the cost is relatively low. I just want to highlight here, like average $2,000. That's just based on the jacket. Like I say, people sometimes we use on the different function, but I just want to give you a general idea based on our data system, probably about 2,000 to 2,500 per jacket. And impressed current system because you have to control the current and the power is from the independent solar. And there's a research or we found that if we don't maintain the right current, sometimes you actually speed up the corrosion. And we are trying to adopt of the remote monitoring system or even remote control. However, there's a concern from our security or IT group, and we are working with and to resolve it. But however, right now, 2 to 6 months, because we also want to check the current and check the functional. 2 to 6 months is our inspection frequency. And inspection including the visual inspection, corrosion development, system function, and like I said, because this is come with the power, routine adjustment is needed. And compared to the GCP, usually we can, if we maintain well, proper control, it can above 20 years more. And unfortunately, the cost is relatively high. Initial cost is about 3,500, but you also want to consider the routine inspection here. And that's the reason why myself and my team, we are keep pushing with the remote monitor system so we can certainly reduce the inspection frequency. Here's the brief of introduction of the CP system. You can see the numbers here. Right now we have about 250 bridge to have the CP system, about 209 with a galvanic system, 37 with an impressed current system. For the past 6 years, five bridge per year have been added to the list. I think till today, this year, I already seen probably 8 to 9 new project coming to my core. So definitely the need is increased. And as you can see, it's kind of be interesting to see this, right? I mean, the CP system you are putting in the bridge is all on the sea coast, and that reflect that under the marine environmental corrosion is a problem and a concern. How we manage this program manager wise? I mean, in the past, because we are in the R&D phase, and again, corrosion won't happen in the near future. It usually takes 30 years. So in the past, we don't really centralize all these projects and the programs. And since the technology improved and the AI, all this database system is there, my leadership and myself, we decide to centralize this program because we learn from the mistake, we learn from the history. What's the centralized can change the game is here. We can ensure the effective corrosion protection. Like I mentioned that before, right design, right strategy for the corrosion is a key component. So with a centralized, you can start to monitor what kind of system you adopt in the corrosion, what's the server size, what's the material in it, and find the best way or optimized way to optimize system for the corrosion, for the infrastructure corrosion issue. Also, with the data-driven and the routine inspection, remote monitoring, we can also be proactive, prevent the system failure early. Put it on the program level, we start to have centralized, not just like get the project done, move on. That will help to be more proactive to do the maintenance on the CP system or bridge. And also, it's not just like bridge have a life, everything have a life. CP system also have a life, I have my life. So that also can help to start to tracking what's the life of the CP system for the different type of CP system. And also ultimately with all this optimization, we can further improve the cost efficiently. Like I mentioned, one pier, 2,000, another one is 3,500. How many pier you are? In your bridge. That's a lot of money. This is kind of be the flow chart with the current project development as State Material Office or our contract will do the inspection and the calibration for the current CP project, and SMO will review inspection report and make some recommendation. Sometimes, yes, we need a new anode, sometimes we need an adjustment. And district maintenance will receive inspection report. So if everything good, we will on the green zone, everything just moving forward. And if it's non-function, which means we need a repair, we might need a new CP system, maybe there's a new corrosion happening. So we will start to work with district maintenance office, start to do the project develop. It just depends on the issue. It could be the simple as the replacement of the anode to the adding the new CP system. So district maintenance office will be initiate the project. SMO as a technical expert, we will review some design and provide some input to there. And State Material Office, when the project initiate, we will provide the engineer support or quality assurance to ensure the CP system is function. Because I also see that even CP system, if they don't install properly, the CP system corrode. There's a wire, there's a metal, it's the same things. We will finish the project, then come into the flow, start to maintenance the CP project by itself. And like I mentioned before, not just FDOT, I think active TOD like TxDOT, NY State DOT, Caltrans, most of the CP system is remain on the special provision, which is just project based. And like I mentioned, FDOT trying to move from the project base to the program level, which kind of be like centralize the resource and proper manage each system. So we have moving the TSP to the developmental specification. I share the PDF with you, and you should be able to bio my link to find the document I have here. So in the FDOT specification system, Division 2 is the construction part. So current developmental specification for the CP system of the steel in concrete has been published. Performance-based specification, because the key is to maintain that active current or active battery, active CP there. Right now, we only have a CP jacket, and we are developing the point anode, arc brazing, or other CP system for upcoming developmental spec updates. And Division 3 in the FDOT system is the material requirement. So you can find all the material requirement on the 939. And as a department agency, the color code is required. You will find more information in the specification. And we're talking about the future. like I mentioned, we have been working on monitoring. Right now, we probably have only 2 or 3 best practice to doing the monitoring, but that's the future. Like I mentioned, prevent the system failure early, be proactive, optimize the inspection frequency, extend the life of the CP system. With the current technology can be done, just like thermometer, smart thermometer in my house, right? I mean, right now everything can be monitoring. And this is the current strategy. I'm moving forward, data-driven performance logistics. We want to use the database, standardize the data for the different system. You can see the voltage change or the parameter change during the daily, and ultimately, we want to use this data to predict the corrosion risk or even adopt that to the bridge management system. And we are also consider AI implementation, how we going to use the AI in the CP system. This is the, I would say, successful research implementation. In the past, impressed current highly rely on the independent power system, but sometimes we don't know we know some rural area or like bridge, they don't really have a power or like a certain structural element. You have to find the power to do the impressed current system. But now we are start to adopt the solar panel and the battery that can help for the retrofit of for the CP system for some specific area. And right now we have adopted this in the Skyway Bridge, and I'm going to introduce in the next slides. So here's the best practice of the Skyway Bridge. I think right now the CP system in the Skyway Bridge, based on my understanding, is the most advanced in Florida right now. We have a remote monitor system, we have a solar panel, and all the corrosion right now is being proper controlled. So this is the project, Skyway Bridge. We have main span about 4.14 mile, and we start to see a lot of corrosion happen nowadays. And you can see we start to tracking our daily impressed current data. And as you can see, our environmental is dynamic. So certain adjustment is needed. And here we show the solar panel system here, so we can retrofit even in the segment bridge inside. Another practice is arc brazing, also people call metallizing. Nowadays, probably last year, we found that when we apply the metallizing, if the 2 arc brazing is too close, there's a hollow effect. Corrosion start to happen in between, and that's also the consideration we are thinking about. Should we keep using this technology in our developmental spec or not, or what kind of requirement we should add in? Mention again, the corrosion is not going to happen in 28 days, one day. This need to be long-term monitoring. So what I can do, because ultimately metallizing, arc brazing, you will need to find a place to use it. And probably right now we are considering if we are going to use the metallizing, arc brazing, or we are require the entire girder to be metallized or to be applied all this technology. Like I mentioned, uneven metallizing lead the corrosion differential. That's what we found. Aging, explosion, degrade performance, high risk in solid lead environmental like the Florida Key, that all leading this hollow effect corrosion problem. We are doing some research right now, and we will make a decision for the future, how we're going to approach for the metallizing. And the other future is we are thinking about the hybrid CP system. Galvanic system is like 20 years, and I know right now on the structural design, we are moving the performance-based design. So same to the CP. We would like to adopt the current condition CP system and improve to save the cost. The idea here is the hybrid CP system running the impressed current during the day, which will plus the solar panel, and running the galvanic CP system during the night. So they were eating the zinc anode during the night. So that might be able to extend our service life of the CP system and further optimize costs, even reduce the inspection period. further. And current challenges for the CP program, obviously, hurricane. I mean, because all this CP system is just attached on the bridge. Yes, we do have a RC bridge. They can survive during the hurricane. But for my wire, for my control box, sometimes we cannot. And we do have an accident. Sometimes both hit the pier, and that's the reason why the routine inspection would be needed. And also we have human factor. I always like to call human factor. So some random people will just curious, maybe they want to doing their own research. So our system sometimes got damaged by the human factor. And also it's very interesting. I mentioned that even CP system, this anti-corrosion system itself got corrosion. How are we going to choose the proper material or the right strategy for the CP system is also the key. And with that, the program side start to collecting the data, standardize the different CP system. I was hoping can address all these challenges in Florida DOT. My vision, maybe, or future, I really want to have a CP management system. Maybe there's some folks from payment. We do have a PMS system. We have a bridge management system, and CP system, I think, is needed in the future. That will help to decide what's the best strategy for the department for the bridge. That's just my slides. Welcome. I think right now it's a question time.
Great. Thank you so much, Oliver. That was really educational. We really appreciate you sharing all that information. Paul Lyles is the former Georgia State Bridge engineer. He'll be leading the question and answer, and he'll be assisted by Dr. Kingsley Lau, who'll come on in a little bit. He's an associate professor at FIU, and a special thanks to Kingsley for helping put together this presentation. So, Paul, take it away.
Yeah, we'll go ahead and get into questions. We had a number of questions that came in beforehand, and we've got some that are coming in now, continuing to come in. First couple of questions I have are going to be kind of related to cost or maybe effectiveness ratio. It says, could you speak to or provide supporting information relating to the level of cost to structure life extension ratio? Do you have any feel for that?
Right now, I only can know the initial cost, and that's the reason why we want to centralize this, start to tracking the service line just like a bridge. That's something we are moving on. So I hope in 20 years we have this webinar again, I can provide that information, or maybe sooner.
Okay, and then do you have any feel at all for does Florida DOT evaluate the long-term effectiveness and cost benefit to cathodic protection in particular?
Yes, definitely. I think the jacket system is being widely used, and we already have some service life number in our mind, and we just need to do some calculation.
Okay, and then how would you plan on measuring and demonstrating the long-term effectiveness and return on investment, that ratio?
At this moment, I don't have an answer because the corrosion scope of the work is diversity. It really depends on how you're going to define the scope. But I would say this, at least this moment, I would like to focus on each element. For example, the CP system on the pier, that will be reflect to the initial cost divided by that square feet of the corrosion, and as the calculation of the unit rate. And for the girder, it's the same things. And the bridge deck may be simpler because they're using the point angle. We are working on those things, and I think that's really good question, and that gave me some idea for the future.
Okay, we have a question here, a couple questions on substructure, and the first one I have is, do you use cathodic protection for buried structures? And if yes, what do you think would be feasible? Do you think it would be feasible?
Oh, I mean, yeah, at this moment, point angle, I think is feasible, and it depends on how much you want to spend, right? I mean, how deep you can go, but usually we don't have too much concern for the deep foundation or like substructure.
Okay, I don't know if Florida has any of the big culvert arch galvanized metal things that's come into play. The other question they had on substructure was, can this be applied to buried steel elements like sheet piling and steel piling, and how could it be monitored?
Yes, they can. For the monitor side, we are working on that. I think we have a couple projects they are using on the sheet pile because they are facing on the Marine Corps. And I believe for those projects, we use the point angle. And also I'm thinking about the metallizing could be work. Then let me take that back. For the new construction, yes, we can. But with the existing, right now, we only can use the point angle.
Okay. Do you use cathodic protection when you tie an epoxy coated rebar to a non-epoxy coated rebar? What's the issue there?
We have a research before. FDOT right now, we don't allow the epoxy rebar because we found that if you they call that micro self corrosion. Once you have a chip, actually the corrosion happen extremely. So we don't use the epoxy rebar at this moment. So that answer I cannot answer. However, we do have the dual coating rebar or triple coating rebar, and usually they perform well, and we don't have any need putting the CP for those kind of rebar.
Okay. There was a question here about for a bridge. How many sample tests cores or whatever, how many do you have to do on a bridge? It's probably going to depend on how long the bridge is and that sort of thing.
It depends really, and usually my team go out, they will do their engineer judgment in the field, but usually we take 2 to 3 core, depends on the area. We take the close one close to the corrosion area, and we also take the one there's no corrosion area, so they can as our standard comparison, just trying to figure out is from the material side, from the environmental side, or from the other parameters. Because sometimes we do see that like chemical component or any leaking from public could also activate the corrosion.
Okay, we have a few system type questions. The first one is, how is Florida DOT integrating all the different systems for operation and maintenance?
For the maintenance, actually, we have a contract, like I mentioned before. The thing in the past, because we don't tracking them, and right now, my team and I, we start to tracking them. So right now we have we have 3 big contracts, so we can do the maintenance, and even my team, that's probably another resource we use. So the boundary is when we use 3 contract for some current CP system, and my team will just focus on the new system or new research on it, and just trying to work with the district. And sometimes district maintenance office, they have their own funding to do the maintenance and the repair.
Okay, and here was a question: how is all the data integrated into Florida DOT's bridge management system?
Not yet. I have my own CP management system. If everyone wants to see, I can share with you sooner or later, but I'm working on it. We are heading to there. That's why I'm saying, like, my topic is the present and the future.
Okay, can you give us a general overview of Florida DOT's corrosion policy for new bridges in the saltwater environment?
For the new bridge, well, the CP system should not be considered. That's my personal own perspective. And I know a lot of people is being promote the proactive CP system, but I'm against to that, because what do you mean by that? You want to failure on your design. So for me, on the corrosion perspective, if you have a new construction, you should never consider the CP system. That's for me. But some people like to put in the fuels in the infrastructure. I'm not against to it. And sometimes it really depends on how you design your structure. That could be the cost problem. You just need to calculate that ROI, like Paul, you mentioned that before. What's the ROI? For example, sometimes we notice that it also depends on the size of your structure. Maybe you increase the thickness, it's even expensive than putting on the point angle. So it really depends on how you design it. And also my team is provide the criteria or classification of the environmental in the structure design guideline, that based on the sulfate, that based on the chloride, that based on the pH.
Okay. Do you have any recommendations which you could do to improve the current standard? Do you have any wish list on there?
Yes, we are working each project right now. The link won't change. but next update will be out in, I expect, on October. So if anyone is interested, and always can go there to look into it.
Okay, a couple of exotic questions here. The first one is, are there any plans to incorporate artificial intelligence or predictive modeling tools into the corrosion monitoring and maintenance?
Yes, definitely. The AI could be the future. I'm thinking about use the AI to doing the remote monitoring or remote control. I think that should be able to do it. And even I'm moving one research project is using the AI to refine the corrosion model. So hopefully, maybe in the future, I can share that more specific with audience.
Okay, we got a lot of questions on cathodic protection, and I'll try and go into those now. The first one was, what type of maintenance schedule is required to maintain cathodic protection systems?
Once a year, usually, we do inspection. Ideally, during the inspection, sometime my team or someone, they will just do the easy fixing, sometimes just the connection or some easy stuff, we will just do it right away. But if it's like hurricane or something, accidentally, we need so usually idea we want to do the inspection here, and we don't want to do any maintenance unless something go wrong. So non-functional will be here. It just depends on how big is the damage. If the small one, we can go to the easy route, but if it's like the CP system is already out of function, we need a new CP system, that we will start the new construction project for the maintenance. It depends. Ideally, once a year for the minor maintenance. The goal is no maintenance.
Okay. You mentioned hurricanes. Do you ever have any problems with lightning?
No.
Florida is one of the lightning capitals of the world, so I was just curious. Let's see. Does Florida DOT require the use of cathodic protection on any new bridges? Just as you're building them?
No. That's why
Okay.
I mentioned. I mean, I personally against to it, but I can also understand on the structural design point. If a certain level you need to drop or reduce the material or the design, point angle could be your option, or trying to be more proactive. And actually, we have one project. It's kind of a research project, and sometime that we want to try the new material or new mix design. And it went on with, during the construction phase, we already have a corrosion issue. So unfortunately, we have to start to put in the CP system in the new construction. But again, the concept here for me is never put the corrosion into the new construction. Yeah, you should know the history, you should know the design, you should have your strategy right here, right? How to stop the corrosion, how you really do the optimized design.
Okay, on slide 30, you had the cost for each, the cost. The question was, is that the cost for each inspection or the per installation at each location?
Per installation, just
Okay.
a new jacket in one
right.
pier.
And is access and traffic control included in the cost for the inspection? Is that separate?
Usually, when we do the inspection, we don't need the MOT. We are on the boat. Yeah.
Okay. Let's see. Have you used bulk anodes, zinc or aluminum for reinforced concrete piles underwater?
Yes.
And do y'all have guidelines or specs for the use of the bulk anodes?
That's all in the developmental spec. And we are, because it's a developmental spec, maybe there's some gap. And that's also, I'm always be very open for any comment or input. Once you review, if you have any question or suggestion, my email is here, so you always can contact to me and we can have organic conversation.
Okay, I'm going to turn it over to Kingsley and let him ask a few of the remaining questions here.
Hi, Oliver. Lots of questions, which is a good thing. So there seems to be good interest in your presentation. So I'll try to consolidate the questions as best I can. And there's one topic that seems to be of most interest. But I think it needs to be applauded that you're trying to implement more monitoring and centralizing data, like you said, learning from the history of things. But considering how complicated the corrosion problem is and the very many different engineering systems and technologies used to mitigate, range from metallizing to different anodes and different energy supplies, how do you leverage all that information that you're going to get from these monitoring systems, and how do you implement and develop guidelines based on those results?
So that's really good question, and that's what my system is working on. We are not just measuring, we are also understand doing the forensics inspection, what caused the corrosion into the different structure type. For example, splash zone, for example, girder, for example, bridge deck. And at this moment, I cannot give you the full picture, but right now, my strategy is treat each bridge as an individual project and separate the key element and also understand each corrosion issue and what kind of CP system already been there and how's their performance. And we will keep tracking this. I'm not sure I can make a decision or having the model or standardize for this yet, but I'm trying to build a database for the future corrosion engineer in the FDOT. Otherwise, right now, my difficulty is once I have the projects coming and I have to spend almost 1 month or 2 months start to finding all the paper document in the past, and it's very difficult to make the right judgment. As you can see, sometimes we are also learning, right? We think the way is that, but if I put it in the wrong system, just like the one I showing on the metallizing, we saw with 5 years ago, we think we solved the problem. But last year, the problems come out. And all this need to be documented under that bridge, just like you have a doctor, they have your profile, so they can help you to be proactive, deal with the corrosion problem.
A lot of information that you're going to learn, I imagine, is going to be site-based or project-based. So there's going to be a lot of information available. How do you imagine you can organize this, and can it be made available to the public? And if so, where can they find it?
At this moment, I'm building the database internally. I'm not sure I can share with you right now. I should be able to. And ultimately, I definitely want to push to the public, because as a department agency, everything should be able to share. But again, not is also follow the Florida statute, trying to share all the information, but not the details. We will see how it goes to based on the language there, but I'm trying to share that database system with audience, and that's where we at now. So we trying to have all the data we have, even we trying to have our bridge map to control all this, and we also including our corrosion map, environmental data, so we can pick and choose to understand the situation, and all this is been working on. So far it's good, and put more to come.
The engineering data is really nuanced, and it can be complicated, and especially we have a lot of data collected. How do you find it best to explain to lay people, whether it be through news or having public available information? What are your thoughts on explaining, the successes and troubles that we have with corrosion to the general public?
I'm trying to leverage that system in the future. Definitely, visualize is the key. So I was hoping that system can be more mature right now. Even I only have a galvanic CP system there right now. I don't have an impress current system. But like I say, I'm trying to build the profile for each bridge. Right now in my system, every time my team or the contract they go out, we have the inspection report or maintenance report there. So my goal is in the future to share with the public. The public have some concern without that bridge. They just need a one click and pull out all the profile, and even including the corrosion issue.
Okay, great. So for those who have really nice technical questions, please contact Oliver. He has his contact information with you. But Oliver, there are a lot of questions on this slide that you have right now with that metallized bridge girder. So the general questions overall is, how do you know, did the metallizing have any effect to accelerate the corrosion in between the metallized portions, or do you think that corrosion just it just was caused by time, essentially?
It could be. It could be both way, because right now it's not settled, because I have another thought is about jet ski, the water splash out to the bridge deck. That could be considered. But again, if no matter it's from the metal or from the jet ski, I think we can do the development, we can put the requirement there. If we are doing the metallizing, we just do the entire girder to mitigate the corrosion. But right now we are still under investigation. My program manager, Shannon Dees, is been keep updating this with me. And this presentation here, this is our assumption or based on the research we have this idea, but further information is needed, further tracking is needed, and maybe research might need to do the small scale. So we are working on to address this concern.
One quick question to throw it in. What is the future in Florida for alternative corrosion resistant materials?
We definitely will work with Natasia's group. Like I mentioned, be more proactive on the design phase. Even right now, we do see some more projects start to using the corrosion resistant of the mixture, and the GFRP definitely is the future. And that's definitely is the way to go. I can see more and more use on the GFRP, even for the coating. We have a lot of new coating system right now. So I just think the more corrosion product will be just put it during the design or new construction phase. The best way is you don't need a CP system. So I just don't need to work at all. So that's an ideal world, but if you are using the corrosion resistant material or chemical inhibitor, that definitely can reduce my workload and reduce the cost of the maintenance. And that's definitely the future.
So thank you so much, Oliver and Nastasia, for sharing your time and your expertise with us. It was really a very interesting presentation. So remember, the presentations are archived on our website, so you can watch those in the future or share them with interested colleagues. And thank you to Paul and Kingsley for helping us with the Q&A moderation. And thank you all for joining us today. And the webinar is now concluded.